Look around you, do you see a road, a building, a bridge? These things did not just appear, they were imagined, they were planned, they were built by people with a grand vision. These people are civil engineers. Their work is the silent backbone of our world. It started thousands of years ago, with the very first humans who decided to change the land to suit their needs. They moved rocks to make shelters. They dug channels to bring water to their crops. This was the beginning of a great story, the story of how we built the world we live in today. It is a tale of ambition, of cleverness, and of changing the very face of the planet. Imagine the land of ancient Egypt. The Nile River was everything. It gave life, but it also flooded unpredictably. The first civil engineers learned to control it. They built canals to move the water. They created reservoirs to store it. This simple act of managing water allowed their civilization to grow and prosper. The Romans came next. They were masters of practical engineering. They understood that to control a vast empire, they needed to connect it. They needed to move armies, supplies, and information quickly and reliably. Their solution was simple but brilliant: roads. The Romans built over 50,000 miles of paved roads stretching from Britain to the Middle East. These weren't just dirt tracks. They were carefully constructed with layers of stone, gravel, sand, crowned in the middle so that rainwater would drain away. An engineer named Vitruvius wrote detailed manuals on how to build them. These roads were so well built that some are still used today, 2,000 years later. But roads were only part of the Roman engineering miracle. To make their cities livable for hundreds of thousands of people, they needed fresh water. The answer was the aqueduct. These incredible structures were long, sloping channels, often raised high on magnificent arches that carried water from distant springs. The Pont du Gard in France is a stunning example, a bridge and aqueduct in one. After the fall of the Roman Empire, much of their advanced knowledge was lost for a time, but the desire to build remained. During the Middle Ages, engineering took on a new purpose. It was driven by two powerful forces. Faith inspired the building of magnificent cathedrals, great stone churches that soared towards the heavens. Fear inspired the building of mighty castles, strong fortresses designed to protect lords and their people. Both required incredible skill and daring from the master builders of the day. They were the civil engineers of their time. They worked not with blueprints and computers, but with experience, intuition, and a deep understanding of their materials. The Gothic cathedral is one of the greatest achievements of medieval engineering. Builders wanted spaces that felt light, airy, and divine. They wanted stained glass windows to tell stories in light. To do this, they developed new techniques. They used pointed arches, which could carry more weight and reach greater heights than the Roman round arch. They invented the flying buttress, an external stone arm propping up high walls. This allowed walls to be filled with huge, beautiful windows. Men like Abbot Suger of Saint Denis pushed builders to create these light-filled spaces. At the same time, the world was a dangerous place. Lords and kings needed to defend their lands. The world began to change again, faster than ever before. The Industrial Revolution brought new materials, new sources of power, and, honestly, some new challenges for civil engineers. The absolute star of this new age was iron. It was way stronger than wood or stone, and it could be cast into new and exciting shapes. Suddenly, builders could span wider gaps and build taller structures than they had ever dreamed possible. One of the first great pioneers of this new material was Abraham Darby III. In 1779, he built the world's first cast-iron bridge over the River Severn in England. The Iron Bridge, as it was called, was a revelation. It was lighter and more elegant than any stone bridge, a symbol of a bold new era of construction. With new materials came new needs. The factories of the Industrial Revolution needed to move massive amounts of raw materials and finished goods. Roads and rivers were no longer enough. The answer was the canal, and later the railway. The 20th century pushed the limits of engineering even further. The new material was steel, an even stronger and more flexible version of iron. With steel, engineers could finally reach for the sky. The skyscraper was born. Chicago, New York architects and engineers collaborating create buildings that seem to defy gravity. Men like Fazlur Rahman Khan developed new structural systems like the tube design that made super tall buildings possible. The Empire State Building, the World Trade Center skyscrapers that now define skylines around the globe, are all monuments to the power of steel and the ambition of modern engineering. They are vertical cities, housing thousands of people and businesses. At the same time, the invention of the automobile created a new demand. A world built for cars. Civil engineers rose to the challenge by creating vast networks of highways and long-span bridges. The Golden Gate Bridge in San Francisco became an iconic symbol of this new age. It spanned a gap once thought to be unbridgeable. These road networks connected every town and city, enabling the growth of suburbs, changing where and how people lived their lives. The world felt smaller than ever before. But engineering is not just about building up and spreading out. It is also about harnessing the power of nature. Engineers built colossal dams like the Hoover Dam, the Three Gorges Dam. These megastructures hold back entire rivers to generate clean electricity, provide water for irrigation, and control devastating floods. They are among the largest and most complex structures ever built by humans. Modern engineers also work on projects we rarely see, like the massive undersea tunnels that connect countries, the vast networks of fiber-optic cables that carry the internet, and the sophisticated systems that protect our coastlines from rising seas. Today, in the year 2025, the work of the civil engineer is more important than ever. We face new and enormous challenges: climate change, growing populations, and aging infrastructure. The engineers of the future must find ways to build sustainably, using new materials and renewable energy. They must design cities that are resilient to extreme weather. From the first person who laid one stone upon another, to the teams designing floating cities today, the story of civil engineering is the story of humanity itself.